In this video, we're going to go over using these different formulas for the perimeter and area of polygons. And to try to make it a little bit more challenging, you'll notice that pretty much all or almost all of these problems are going to involve some type of combination of one or two different polygons, as well as maybe some chunks taken out. So it's going to require a little bit more than just kind of plugging into a formula, okay? All right, so start with number one. We're going to find the perimeter and area of this triangle, and then it wants us to leave our answer in simplified radical form or in terms of pi. So in this first one, they're telling us that the height of this triangle is 10 feet. So I'm going to draw that 10 feet right there. And when I do that, it creates a right angle. So based on the markings in the figure, right, you'll notice this is an equilateral triangle. So all of these are 60-degree angles. And then this actually cuts it into 30 degrees. So I'm going to be using my understanding of 30, 60, 90 right triangles to find some other measurements on this triangle. All right, so if I'm given the leg that is across from the 60-degree angle to get to my shorter leg across from the 30-degree angle, I'm going to do 10 over the square root of 3. Now I am going to simplify that, right, like we did in our unit on this, right, and multiply by the square root of 3 over the square root of 3, which gives us 10 root 3 over 3. Okay, so those are the same thing. One is simplified, one is not. So I'll be writing this one that doesn't have a radical at the bottom. And then to get from the smaller leg to the hypotenuse, I'm going to double that. So 10 root 3 over 3. So I'm going to multiply by 2. So times 2 will give me 20 root 3 over 3 as the length of one of our sides in this triangle. All right, so now I have enough information to find the perimeter of this triangle, which is just going to be 20 root 3 over 3 added together 3 different times, because I have 3 sides. Feel free to write this as repeated addition is multiplication, which is how I'm going to write it now. So 3 times 20 root 3 over 3. And then this large 3 out front is going to cross out with the 3 in the denominator to give me that the perimeter is equal to 20 times the square root of 3 feet. Okay, let's find the area. Now the area we know is base times height over 2. All right, and so when I think about my base, all right, I see this 10 over root 3, which I know is simplified right here. All right, so this one is also the same, 10 root 3 over 3. So my base is my side length. So I'm going to multiply my side length of 20 root 3 over 3 times the height. I know the height was actually the very first thing they gave us, which was 10 feet. And then it wants us to divide by 2. Now I know I didn't kind of write it as I put it here in my formula, right? But that's just because I have more fractions going on. So I wrote it like that, which is still the same thing, right? That's our base times height divided by 2. And then I'm going to go ahead and simplify that. All right, my brain sees the 10 over 2 becomes 5. 5 times 20 is 100. So 100 times the square root of 3 over 3 square feet. All right, and that is how you find the area for that triangle. So that was using a lot of different things that we've used in the past unit or in past units. So make sure you are locked in on seeing these 30, 60, 90 triangles if they show up. Okay, number 2. All right, so number 2 has a square, right, and it has a semicircle. All right, so each of these are 6 centimeters as well. All right, so in order to find the perimeter, I need to first find the circumference of this semicircle. Okay, so circumference is equal to 2 times pi times the radius, or you can use pi times the diameter. But just keep in mind with this question number 2 that we are looking at a semicircle, so half of that. So whichever one you choose, I'm going to choose this one because they gave me the diameter is 6 centimeters. I need to put it over 2. So that's going to be pi times the diameter of 6 centimeters divided by 2. So the circumference is equal to 3 pi centimeters. All right, Now I'm going to find the distance around for this part of the square. The common mistake here would be to include the fourth side of that square, but you should not because it's the distance around this figure. So the perimeter is actually going to be 3 sides of the square, so 6 plus 6 plus 6, those 3 sides, and then plus that circumference, which is that 3 pi. So the perimeter of this shape is going to be 18 plus 3 pi centimeters. All right, let's do the area. Now we can find the area of the circle by using pi r squared. But remember, this is a semicircle, right? So if I want to find the area of a semicircle, I need to put it over 2. All right, so it's going to be pi times, so the radius is going to be 3 centimeters divided by 2. So that's going to be 9 pi over 2 square centimeters for the area of that semicircle. So the area of this figure is going to be the area of the square, which in this case is just going to be side squared, or 36 square units, or square centimeters, plus 9 pi over 2 square centimeters. All right, so that is it for number 2, finding the perimeter and the area. Let's do number 3. Now, number 3 is a parallelogram, all right? And when I look at this, it's giving me, basically telling me to draw this as a right triangle. And if this side over here is 60 degrees, then this one is 120. So then this one is also 60. This one up here is going to be 60. So then this one inside is going to be 30. So again, I've got that 30, 60, 90 triangle happening like what happened in the first question. This time, 14 is the hypotenuse. So to get to the smallest leg, I'm going to divide by 2 to get 7 units. And then to get to the height or the leg across from 60 degrees, I'm going to do 7 times the square root of 3. So that is going to help me find the area, all right? But to find the perimeter, we actually have everything we need, right? This is 21, that is 14. So we can go ahead and find the perimeter by doing 2 times 21 plus 2 times 14. This one doesn't give me an actual unit, so I'm just going to write units. So let's see, that's 42, that's 28. So that's going to be 70 units for the perimeter. All right, let's find the area, right? The area of this parallelogram is going to be base times height, and this base is 21 units, and then the height is going to be 7 times the square root of 3. So the area for this parallelogram is going to be 147 times the square root of 3 units squared. Okay, that's number 3. Let's try number 4, another triangle. So it is an isosceles triangle, so I know this is going to be 13 as well. I'm going to draw that altitude coming down to make that 90-degree angle, right? Which is also going to split this in half to be 5 units for each of the part of that base. And then what I'm going to do is notice that this is a right triangle. I have this one memorized. If you don't have this memorized, 5 squared plus the height squared equals 13 squared. You can use your calculator or do your math for that. But I know that if you have a right triangle where one of the legs is 5 and the hypotenuse is 13, then the other leg has to be 12. So our height is 12. So finding the perimeter, that's just going to be 13 plus 13 plus 10. So that's going to be 36 units. And then finding the area is base times height over 2, which is going to be the base of 10 times the height of 12 over 2. And so that's going to be 60 square units. All right, so that's it for the 4th one. All right, I went ahead and did the 5th one already, so you can take a look at that on our key. So we only have 3 more to do. I'm going to do 6, 7, and 8 to finish off this video. Okay, so finding the perimeter and area of the figure. So first thing I notice is if I kind of draw dotted lines here, I can make this into a rectangle, all right? And so I can find the perimeter of that rectangle and then subtract out the perimeter of this. It looks like it's a semicircle, but there's 2 of them, so it's really just one circle. So the circumference of that, and that would give me the total perimeter, or I should say the perimeter of the figure. So let's find the perimeter of the rectangle. So that's going to be 15 times 2 plus 8 times 2. So that is going to be 30 plus 16. So that's 46 units. And then I'm going to find the circumference of the circle. And I'll use pi times diameter since they gave me the diameter. So that's going to be pi times 8. All right. And when I have that, that's going to be 8 pi units. So to find the perimeter of the figure, I need to subtract out the circle, and that would give me the total perimeter of this. So I'm going to do 46 minus 8 pi units. That is the perimeter of this figure. Now for the area, kind of similar idea here. I'm going to find the area of the rectangle. Then I'm going to subtract out the area of the circle. Now give me the area of the figure. So area of the rectangle is going to be 15 times 8, which is going to be 120 square units. And then for the area of the circle, that's pi r squared, which is pi times the radius is going to be 4 centimeters squared. So that's 16 pi square units. So the area of the figure is going to be equal to 120 minus 16 pi square units. All right, and so that is the work for number 6. And a good one to try is number 5. Very similar. Let's do 7. We're going to draw a rectangle. And it tells me the diagonal is 13 units. And the width is 5. So I'm going to find the length by using Pythagorean theorem. I already touched on this one in a previous question with if your hypotenuse is 13 and one of the legs is 5, then the other leg has to be 12. All right, so that means this is 12 up here and this is 5. So perimeter is going to be equal to 12 times 2 plus 2 times 5. So the perimeter of this rectangle that's 24, that's 10, so 34 units. And for the area, that's going to be our length times width, which is 12 times 5, which is 60 square units. Okay, that was probably the most straightforward one. Just had to draw your own figure. Last one here, number 8, bringing in some stuff from earlier in the unit. So we're trying to figure out the perimeter and area of the shaded segment. I'm going to start with the perimeter. And again, this is a circle. So when I say perimeter here, I'm actually just asking for the arc length of this. So I'm going to write down the arc length formula, which is the measure of that arc in degrees out of 360 times the circumference, which in this case I'll use 2 times pi times r. So plugging in my 90-degree arc length, right? This is 90 degrees out of 360 times 2 times pi times the radius is 6. My arc length, if I reduce 90 over 360, that's 1/4. And then 6 times 2 pi is 12 pi. So dividing that gives me 3 pi units. So that is the arc length of that shaded area or shaded segment. And now to find the area of this shaded segment like we did in a couple videos ago. So the area of the shaded region is very similar to this. We have that measure of that arc out of 360, but now we're multiplying it by the area of the circle, so using pi r squared. So I'm going to go ahead and plug in, that is still 90. Try that again. Over 360 times pi times 6 squared. So that's going to be 1/4 times 36 pi. So dividing that gives me 9 pi square units. So 9 pi square units is the area of that shaded region. All right, guys, so that's it for this video. There's some problems at the end here on try on your own. Check out the key and come see us with any questions.